Hello friends, so today's question: a 25 kg block A rests on an inclined surface and a 15 kg counterweight B is attached to a cable as in figure. Neglecting the friction, determine the acceleration of A and the tension of the cable immediately after the system is released from the rest. So this is block A, which is weighing 25, and block B, which is connected with the help of a cable and is as a counterweight for the A, and the incline is at an angle of 20 degree. So let us first find out the constraint for the cable. Constraint of the cable. So if the block A moves through a distance of xa, okay, you can say block A moves through a distance of xa, then the movement of block B will be relative to block A. You can say therefore the distance moved by block B will be a relative to block A, and let us suppose that is given as YBA, as the length is string is constant, so we can say that our XA plus YBA is equal to 0, and if you double differentiate this equation, you can say acceleration of A plus acceleration of relative acceleration of B is equal to 0. From here we can say that A and this is negative of BA. Okay. This is the constraint relationship of the cable, and we can also say that the B will be having, you can say, acceleration in along because of the block A, and another one will be because of the free movement with the help of the gravity. Okay, so there are two accelerations that will be associated with it. So we can draw for block B. So we can draw the for block B. This is a block A, and this is a block B. So block B, we are going to have MBG in the downward direction, and let this angle be theta, which is 20 degree. So we have two components. This is our theta. We have MBG cos of theta, and this will be MBG sine of theta, and there will be tension T, and there will be normal in this direction. Let us call that NB. Okay, and for the acceleration of B, let us denote this as B. So it is having two accelerations in this direction, which is according to acceleration of block A, and there will be in this direction there will be relative acceleration, which is BA. So the net acceleration of this will be equal to AB, and from here we can say that AB is equal to acceleration of A plus acceleration of BA. this is our block B. So let's write the equation for block B. You can see that MBG theta is 20 degree. So we can say MBG sine of theta minus the normal NB. This will be equal to our acceleration MB in A direction. Okay. And if we substitute the value, we get this as weight is given as 15, so this will be 15A plus NB is equal to MB is our 15, G is our 9.8, and this will be sine of 20 degree. So from here we can write that our NB is equal to 50.32 minus 15A. Question number 1. And in the y direction, so we can say that for y direction we have MBG cos of theta minus t is equal to, we have acceleration of, this is A, B. Okay. Next, we substitute the values, okay, and we can add this equation will be coming equal to as, we have our MB ABA, and this will equal to plus tension T is equal to MBG cos of theta. We put the values is 15 ABA plus T, and this will be MB is 15, 9.8, and cos of 20 degree. From here you can say our tension T is equal to 138.25 minus 15 AB. Question number 2. Now let us draw for block A. You can see that for block A, theta, and we have this block A. So in the downward direction we have MAG. There were two components. This is theta, so we have MAG cos of theta, and this will be MAG sine of theta. And here we have tension T, and here is tension T. It is moving in this direction with the acceleration of A, and this is normal NB. So we can write this equation. We can say that our MG sine of theta, MEG sine of theta and minus tension T and plus normal NB is equal to MA. So we just put the values. MA is given as 25, so we have 25A minus NB plus T is equal to MA is 25, 9.8 and sine of 20 degree. So this can be written as 25A minus NB plus T is equal to 83.88. Let this be question number 3. So we are going to use value of NB from equation 1, value of T from equation 2. So using equation 1 and equation 2, and also we know that acceleration of A is equal to negative of BA. So we are going to use in equation 3. So we get this as 25A minus our NB was 50.32 minus 15 of A, and our tension T was 138.25 minus of 15, and we put this as minus of A is equal to 83.88. So if we solve this, we are going to get acceleration of A is equal to minus of 0.740 meter per second square. Now we have assumed that acceleration of A is in along the inclined plane in the downward direction, but because of this negative sign, okay, so this clearly indicate that acceleration of block A block will be up the inclined plane with the acceleration of A. Okay, so you can say this is upward along the inclined plane. And we are supposed to find out relative acceleration also, so we can use equation 1, okay, or this relationship rather. So we say using acceleration of BA is equal to minus of acceleration of A, so we get this as plus 0.740. Sorry, my mistake, this is 0. This is our acceleration of BA. And finally we are going to find the tension T, so we can use equation number 2. Using equation 2, which is T is equal to 138.25 minus 15 times BA, and our tension T comes as 137.2 newtons. So this concludes the question. Thank you.